Okay, we have a really fun, interesting, creative integral here today. It's going to require some outside-the-box thinking a little bit, but I'm going to show you how it all works. It's actually really cool. So it's the integral from 0 to 2022 pi of sine of x minus x. So we start pretty simple. We're just using some normal trig formulas, that top one up there, sine of a minus b, just to expand this term. So we will still have the integral from 0 to 2022 pi, but the trig part will turn into sine of sine x times cosine x minus, it will be cosine of sine x times sine x dx. Now we're going to use this second part here, which states that the integral from 0 to n pi of sine x, where n is an even number, is going to equal 0. And we can visualize that for ourselves. So let's say this is just 0 to 2 pi, and this is our sine graph. It's going to look something like that. And this area is the same as this area from 0 to an even pi of sine x. And because integral calculates area, and area above the x-axis, you have to cancel over the integral below the x-axis. Because these are equal, and we're supposed to cancel them, this is just going to equal 0. And that's how that formula comes to be. And now notice, this is 0 to 2022 pi, which is an even pi value. And we have a sine x here. So when all is said and done and evaluated, this part's going to be 0. It's going to multiply by some other step in the antiderivative, but 0 times anything is 0. So this whole section right here, this just equals 0. We don't have to worry about it. So all we have to worry about is 0 to 2022 pi, or 0 to 2022 pi of sine x times cosine x. Now there's a few ways we can evaluate this, but a way I really like is to do a u substitution. We're going to let u equal sine x and du equal cosine x dx. Ignoring the bounds for now, that's just going to give us sine of u du. But if we plug in the bounds, sine of 0 is 0, and if we plug in 2022 pi, that's an even pi value, and so sine of that's going to be 0. So it's integral from 0 to 0, and we all know the integral from a to a of anything, that equals 0. So this whole thing equals 0, just like that. So this part equals 0, this part equals 0, the whole entire integral equals 0. It's just a really interesting way of bringing it all together to get one of the most common, simplest numbers in mathematics.